Hello, this is going to be part 2 of the Chapter 9 Examples of Rigor. This is Cluster Target B, so this is all about transformations of radical functions. So I'm going to give you some radicals. We're going to define all the transformations that exist in those radicals. Okay, so if you take a look at number 7, it says, consider the function h of x equals the fourth root of x, right? So that's the original, that's the parent fourth root function, if you will. So it says, describe the transformation of this function that you can use to obtain the graph of the function g of x equals the fourth root of x plus 3 minus 7. So ultimately, what are the transformations that I have inside of g of x, right? So what we have here, if I add 3 to the inside, that's going to be a horizontal translation of left 3 units, okay? And then the minus 7 is going to be a vertical translation down 7 units, okay? And those would be the only two transformations in g of x, all right? So let's take a look at B. Describe the transformations in this function that you can use to obtain the graph. And I have a couple more things here. So now if you notice, there's a negative out front. And if there's a negative in front of the radical, that's going to be what we call a reflection trying to be neat here. Over the x-axis, okay? And then with the minus 4 on the inside, we've discussed that one on the previous question. That's going to be a horizontal translation of right 4 units, okay? For number 8, it says the graph of m of x is obtained by vertically stretching the graph of the function g of x equals the cube root of x. So we're starting with the cube root function, and we're going to vertically stretch it by a factor of 2, okay? And then we want to translate it 3 units to the right. So what would that look like? So one, they wanted us to label this function m of x, and I know I'm going to start with the cube root function, okay? And I want to vertically stretch it by a factor of 2. Well, all vertical dilations are multipliers on the outside, so I'm going to give it a little coefficient. And if I want to move it 3 units to the right, I'm going to say x minus 3. And that would be the function for m of x, okay? Now, number 9 says let h of x be a transformation of the function f of x equals the square root of x. Write the equation for the function below this, h of x here. So this graph is of h of x. Now the original, I don't know if you guys are aware, but you can use your calculator, or you can use Desmos. The original square root function starts at the origin, right? So if I go from the original to this new graph here, I want to know what transformations took place. And it looks like there was like a shift to the right and a shift down. So I think it went to the right. Let's see here. It went to the right 4 units, and it looks like it went down 2 units to get to that new location. So if I can take that square root function, we're going to call it h of x. I'm going to start with the square root. I want to shift it to the right 4 units. So I'm going to say x minus 4 on the inside. But then I want to move it down 2 more units, and I'm going to put a minus 2 on the outside of the radical. And that would be the equation for h of x. Okay? Now, some other things to consider that were not on this EOR. On the previous worksheets and assignments, I had you translate or do transformations to a table of values. I think that is important. So for any assessment, make sure you can still do that. And if you have any questions, again, please email me, let me know. Go back to the old assignments and videos to help you prepare for cluster target B of chapter 9.